So we've already talked about method 2. Make sure that we are looking at A times C. Find the factors of AC that can add up to B. Separate the B term, and then you can factor by grouping. So let's look at the same example we did yesterday using brute force, guess, and check. And let's follow our 6 steps here. You can clearly see A is not equal to 1. Right? A is equal to what? 12. So therefore, I cannot just find the factors of 45. That will give me 69. It's not going to work. Now, step 1 says put it in standard form. Is it standard form? Yes. 2, do we have a GCF? We have a greatest common factor. Yes, we just did this problem, guys. It happens to be 3. So I'm going to take a 3 out. Now, I take that 3 out. Notice that I did not throw it away. The 3 is just not gone. I've got to keep it around because it's part of the problem. Notice there's no equal sign, right? I'm not able to divide both sides by 3. So I'm just going to take it and say, hey, I'm going to on-distribute factor this 3 out and say, I'm going to leave you up front. I'm going to put you over here. It's kind of like what you do for your younger siblings, right? You go sit over there. Okay? That's what we do, right? And so then what we're going to do is that now we create a new quadratic, and there it is. 4x squared plus 23x plus 15. Smaller numbers. And most of our minds equates to easier problem. And so I'm going to leave that 3 out there, but I'm not going to touch it right now. I'm not going to do anything with the 3, but I will go to step 4 and say I need to choose the factor pair that adds up. Oh, sorry, 3. Sorry, whoa, skipped over 3. Find the factor pairs of A times C. What's A again? So 4 times C, 15, which is 60. Now we've got to find all the factor pairs of 60. 1 and 60. 2 and 30. 3 and 20. 4 and 15. 5 and 12. 6 and 10. Any others? I don't think so, huh? Now, of these factor pairs, are any of those able to get me a 23? And the answer is yes. And it would be the pair of 3 and 20. So what does this mean? It means, guys, I am going to go to 23, and I'm going to rip it apart. I'm going to break it into 2 different numbers that when I put them back together, I get 23. And those numbers happen to be 3x and 20x. Secret, guys, the order does not matter. Because what I'm going to do is I am going to, again, leave 3 outside. Maybe put a bigger set of brackets. 4x squared, I'm not touching. Plus 15, I'm not touching. But I am going to take 23 and break it up. I'm going to break it to a positive 3x and a positive 20x. The order does not matter. I could do 3x plus 20x or 20x plus 3x. It'll work. So what I usually try to do is say, hey, since I got 4, what number with 4 would be able to be factored? The 3 or the 20? The 20, because something goes into 4 and 20, but not 3. So I generally choose that something should go with the first group, so I do that. Which means it's got to be plus 3x. Does everybody see 4 terms now? We like that. And now I can factor by grouping. Remember, factor by grouping, first two, last two, including the sign. What can be taken out of that first group, guys? Can be what? A 4x. What's left over? X plus 5. What can be taken out of the second group? A 3? What kind of 3? A positive 3. And if I divide that or factor that out, I get x plus 5. Notice now it's factored by grouping. I have a common group of x plus 5 that I can take out. And so the 3 was still there. I never moved it. And then I pushed the other parts together. This, guys, is what we consider a fully factored solution. Where's the 3? Out front. If the 3 wasn't out front, some people might have 3x plus 15 times 4x plus 3. Or they put the 3 in the second group, so it's x plus 5, but times 12x plus 9. The 3 cannot go in both. It can go in one of them or the other. But if I wanted to factor it, it means to take all pieces to their smallest, not keep things together. Any questions on that? So what I want to do now, I want to do the exact same problem. But this time, I'm going to skip over step 2. Our answer is going to be at the end the same. It's the same question. I'm going to skip step 2 and say, if I have this quadratic polynomial, and I want to factor this, and I skipped or didn't realize that there's a 3 in everything, I'm going to follow the same rules. What's a now? What's an a originally? So it would be 12 times 45. What is 12 times 45? 500. 540? So now we got to find the factors of 540, guys. That will get me to 69. 1, 540. 2, 270. 3, 5 plus 4 plus 0 is 9. 9 is divisible by 3, so it's definitely divisible by 3. What's 3? 180. 4? 90. 5?
45.
5 and 45?
4 would not be 90.
4 would not be 90. That seems a little low, isn't
It'd
it?
be 360.
Ah. 4 and 360?
What? No. 4 times 90 would be 360.
Yeah, 4 times 9 would be 360. Oh, these last two don't seem right. What's 4? 4. Is it divisible by 4? Well, think of this. Isn't 2 and 270, if I move a factor of 2 to the other side, what's 270 divided by 2? 135. 5. 108. 108. 6.
90.
6 times 90. 7. I don't know. 8.
No, it's like 67.
Okay. 9.
60.
60. Any more? 10?
54.
And we could keep going, right? But do I need to keep going, guys? Why can I stop? Do we have a factor pair that will give me the number I want? We do. And that number happens to be 9 and 6. Yes? So, I'm going to move this over just a little bit. Give it a little bit more room. So we're going to use 9 and 6. So I split it up. 12x squared. Let's do plus 9x plus 60x plus 45. And all you have to do is factor by grouping. What can it take out of the first group? 3x. What's left? 3. What can I take out of the second group? More than 5. 60 needs to become a 4. So it's 15, a positive 15. So that becomes 4x plus 3. Hey, 4x plus 3 is common in both of them, right? So 4x plus 3 times 3x plus 15. We factored it. The question is it completely factored? The first group completely factored? Yeah, I can't do anything. But what can I take out of the second group? A 3. So 3 should go out front. And those two groups are the same. Remember, order doesn't matter. So they are the same. Okay, try this one on your own. Start to finish, go. Okay, so A is equal to 2 this time. So I can't use the old school method, or as in the A equals 1 method of just factors of 2 that will give, or factors of C that will give me B, because there are no factors of 1 that will give me a negative 1. So, interesting. So that means I have to do 2 times 1, which is 2. Now, why did I skip over the fact that that's supposed to be a negative 1, isn't it? I skipped over that fact because I can always assign a negative in the problem. I know my answer has to get to negative 1. You guys also realize that since C is negative 1, that you're going to have to multiply a positive and a negative answer? Okay, so one of them has to be positive, one has to be negative. It's the same thing for this step. What are the factors of 2? It's just 1 and 2. Oh, well, that's not too bad. I only got one choice, right? Now the question that you need to ask yourself is, which one of the 2 or the 1 gets the negative? I have to get to negative 1. Yeah, so it's minus 2n plus n, right? Minus 1. And now you can factor by grouping. I group and I group. What can I take out of the first group? 2n, leaving me with n minus 1. Wait a minute. That's already what I have, isn't it? But I'm forced, guys. My hands are tied. When I do factor by grouping, I need to take something. What do I take then? A 1. In this case, a positive 1. Because a positive 1 will leave it unchanged. And so, n minus 1 times 2n plus 1. Can I factor any of those anymore? Can I take anything out of each one? Or any of them? The answer is no. So we're done. We're happy for that. You guys starting to get the idea here? Okay. I'm moving on to the next one. 4r squared minus r plus 7. Give that one a try. It's been about 20 or 30 seconds. Anybody ever hit a roadblock? Get an answer? Guys, this is not factorable. 4 times 7 is 28, right? So 1, 28, 2 and 14, 4 and 7. Anything else? Now here's the thing. We need one of these three pairs to be able to get us to 1. But we know that our final C value is positive. That means that both 1 and 28 have to be positive, or 1 and 28 would have to be negative. Because they have to multiply together, that type of thing. But anyways, even if I just decided, can I add or subtract these things together? Can 1 and 28 ever become a 1? How about 2 and 14? Add them, subtract them. 4 and 7? No. Guys, this is not factorable. Or the book will call prime. Do not use the word no solution, because there's still a solution to that quadratic if I had to solve it. It may not be real, it may be imaginary, but there's still a solution. Because remember, a solution is like x equals 2 or x equals 3. It's not being factorable or not. Okay? And something's not considered to be prime if you can take a common term. So if there was a 2 in all of those, and I took the 2 out, officially you have factored the problem. So it's kind of interesting. So you just have to use the word, it's prime, and you're done. Guys, this is the cool thing about this. I'm going to go back. Let's go back to this crazy problem. Okay? If I change this problem to say this, right? We have to go back to that point where you're like, oh, 12 times 45, right? Which was 540. And then we had a long list of options. None of those options would be able to add up to 70. You say prime. But if I was using the old school method, and I did the factors of 12, and I did the factors of 45, and 5 and 9, right? You have 18 combinations. 18 of them. You would have to check all 18 and show they all don't work before you can say, it's prime, it's not factorable. That's going to take a long time. But how long does it really take to make a list of factors? 20 seconds, 30 seconds, especially if you have a calculator. And at that point, within 30 seconds, you will know if it's factorable or not. That's the power of this method. I think I'd rather do this method than the other. And the last problem we have to get through is we need to solve this quadratic. Now, I know I threw some hints out there. You can watch the last videos for these. The hints were, it has to be in standard form, right? And you got to factor it. But to do that, I said get everything on the same side. But I also told you guys, to make your life easier, you're going to want this to be this way. What was that? What? Equals 0, that's all. Bring only one to side. But it's more specifically to what side. You want what to be what. It's going to make your life easier. You don't have to.
Positive.
What's positive?
130.
The 30 to be positive, not necessarily. That's not the one I'm worried about. The first term. The first term or leading term in this particular problem would be the negative 4x squared, right? I don't want to deal with negatives as a leading term. So therefore, I'm going to bring everything to the right side. So add 4x squared minus 19x. So 0 equals 4x squared minus 19x minus 30. Now I can factor it just like we've been doing. 4 times 30 is 120. What are the factors of 120? 1 and 120. 260. 3. 40. 4. 30. 5. 24. 6. Wait. Can I stop? Why can I stop there? Because 5 minus 24 will give you a negative 19. Okay. So 0 equals 4x squared minus 24x, but 5x put back positive. And now you can factor it. 4 terms. First 2, last 2. What can I take out of the first group? 4x. What's left? X minus 6. What would I take out of the second group? A positive 5. X minus 6. So 0 equals x minus 6 times. And guys, if I told you were done, I would be lying to you. Because we're not. It doesn't say factor, it says solve. So we're solving by factoring. Guys, we did this problem already too. When you have two things multiplied that equal 0, one or both will equal 0. So that means x equals 6 is one of them. Subtract 5. Subtract 5. So 4x equals negative 5. Divide both sides by 4. So x equals negative 5/4. Not negative 1.25. Let's keep it in fraction form, improper, if need be. So we got two answers, 6 and negative 5/4. If you were to plug that into this original equation, the left-hand side should equal the right-hand side, you'd be done. Check your answers. Your homework is the worksheet, and I want you to do the odds because the answers are on the back. Have a great day.